Hello guys, how are you doing today? Welcome back to my channel Factastic. Today we are going to see about the life of a star. Without any further ado, let's dig in. The exact lifetime of a star depends very much on its size. The massive stars use up their fuels quickly, which means they may only last a few 100,000 years. Smaller stars use up their fuels more slowly as compared to the bigger stars, so will shine for several billion years. All stars form in nebulae, which are huge clouds of gas and dust. Though they shine for many thousands and even millions of years, stars do not last for forever. The changes that occur in a star over a time and the final stage of its life depends on the star's size. Nuclear reactions at the center, or which we also known as the core of a star, provides energy which makes it shines brightly. This stage is called the main sequence. Eventually, the hydrogen which powers the nuclear reaction inside a star begins to run out. The star then enters the final phases of its lifetime. All stars will expand, cool, and change color to become a red giant. What happens next depends on how massive a star is. A smaller star, like the Sun, will gradually cool down and stop glowing. During these changes, it will go through the planetary nebula phase and the white dwarf phase. After many thousands of millions of years, it will stop glowing and become black dwarf. A massive star experiences a much more energetic and violent end. It explodes as a supernova. This scatters materials from inside the star across space. This material can collect in nebulae and form the next generations of stars. After the dust clears, a very dense neutron star is left behind. These spin rapidly and can give off streams of radiation known as pulsars. If the star is especially massive, when it explodes, it becomes a black hole. Stellar evolution refers to the large-scale, systematic, and irreversible changes of the structure and composition of a star over the time. The initial mass of a star is the overwhelmingly determinative property of the evolutionary path that a star will follow. Now let's see why the stellar evolution is so important for the stars and for our own galaxy. One main reason why the stellar evolution is so important for us is because stellar evolution in the form of these fuel consumption stages and their finality is important because it is responsible for the production of most of the elements. Moreover, stages in the life of a cycle of stars are vital in the part of formation of galaxies, new stars and planetary systems. So guys, if you like learning about the life of a star, do like this video, share and subscribe. Thank you so very much.